Welcome to the second part of the unpacking demonstration video, which is associated with chapter number 14 of the reverse engineering course. So let's start by running this executable packed with pcompact with some extra protection features enabled, as for example anti-debugging tricks and import protection. We're going to see what this means during this video. So let's load it to Oli Debugger. And we can see the familiar to us entry point. Let's just press F9 to run. Here is the familiar memory access violation exception. You can see here the address of the exception handler, but in this case let's just press Shift plus F9 to run, and we see that there is another access violation here occurred at this point. Let's try and press Shift plus F9 once again, just to pass the exception to the application, and again, and we see that the process terminates. So something didn't went as we were expecting while we were running this application through the debugger. So let's repeat again, Shift plus F9, Shift plus F9 again, and once we break here at the second memory access violation exception, let's take a look at the stack. You can see that there is a call performed in this address here. This is actually the return address. So if we go there, we can see that there was a call performed at this point here. If we scroll up to see which is the base address of this section of this allocated memory area, is 99 and then 4 zeros. So if you go on the memory map, we're going to see that this is outside our PE image in memory, so this has been allocated later. Let's also see something more at the stack. We can see here a return address which is in an address inside the PE image address range. So let's go to this address there, and let's place a breakpoint here and try to run the application again. So now we stop here and let's just step in. You can see some slight obfuscation, for example in this jump that we showed once we entered the function. Let's keep stepping over. So we see again that something went wrong. So let's try and do this again and try to be more careful this time. Let's step in. You can see that it's going to call the isDebugger present API. So if this API returns 1, we are busted. Indeed it returns 1, so let's change this to 0. And let's place a breakpoint at the end of this function. Step over. Let's place a breakpoint at jumpx, run. and then step over again, and let's analyze with Control plus A, and we see that we are at the entry point, at the original entry point of the application. But let's take a look while we start step over at this pointer here. We know that in this type of entry point, Microsoft Visual C++ 6, the first call should be a call to get version API, but instead here we see that it points to an address, this one here. And if we follow in dump again, we can see some values here. Let's try and go on that address. You can see that it indeed is going to get that value, the address of get version, and then jump EX. But obviously these are redirected pointers, so here there should be already the address of get version. Instead, pcompact has redirected those pointers, so you follow this address and then you go to a piece of code that pcompact has allocated to move the right value of the right address of the specific API to EX, and then jump from there to that API. So if you scroll up just to examine, you see that not all pointers have been redirected. For example, the pointers for APIs that belong to the GDI32 DLL are fine. Same for ADV API 32, user 32, WinSpool. You see these pointers are not redirected. Here we can see some other redirected pointers. So let's try and see what really happens. Let's try and place a hardware breakpoint on this address here. So we are going to see when it's going to write a good pointer to the import address table. Okay, let's restart. Let's zero out the being debugged by, so this debugger present API will not trigger the debugger check trick. Let's run with Shift F9 and again and again and again until we see something more interesting. Okay, so when we stop here, you see that this is the address of the reclose key API and was placed on these two addresses here. Let's see where EDX points. EDX points to the first one in the import address table. You see that the address that should have been redirected are already redirected. So let's try and understand when the redirection occurs. So let's now from this point start stepping over and see, because this is the loop where the addresses of the different APIs are resolved and written to the import address table of the protected application. So let's enter this call here, and what we can see is that it checks here if the base address of the current DLL, for which is going to get the addresses for the needed APIs, matches the base address of kernel 32 DLL, and if it is, this jump is not going to be performed, and it's going to arrive here and call virtual alloc. So it's going to redirect also those APIs. So let's say that this was inside kernel 32, which is not. So I'm going to continue the execution from here. And at this point it's going to bypass this call. So if we want really to check about that, what we can do is go back and let's place a hardware breakpoint on execution at this address here, which is virtually allocated every time, so next time might not be the same, but let's try. So I'm going to load again, shift plus F9, shift plus F9, and again and again. But this time we forgot to zero out the being debugged byte, so we need to do this, otherwise the debugger check trick is going to be triggered. We have only this we can remove now, and just let's try now to do something else. Let's try to place a breakpoint at get proc address. Let's start running again. You see, the first API is going to retrieve is the exit process. So let's press Ctrl plus F9 to execute till the return address, and then F8, and you can see that it's going to store this address into this memory location here. Let's place a breakpoint here and run. Let's continue the stepping. Let's use get proc address again, a breakpoint here, and run. And again, let's place a breakpoint at the end of get proc address and go back. So as you see, it stores those addresses here. So let's place again a breakpoint at get proc address. Then gets again the address of virtual alloc. So this is a loop where it retrieves some APIs for its own functionalities. So I place a breakpoint here and run. So we see that here it's going to perform the is debugger present check, but we have not out the being debugged byte, so we are safe. Let's press enter to see what's inside here. Then again here. So now let's put a breakpoint again at get proc address and run. Let's press Ctrl plus F9 to stop at the red instruction. Step over again. And as you see here, it's going to check now if this DLL belongs to, it has the same base address with kernel 32 DLL. So this is where the redirection happens. So we're going to change this with jump, so it will always jump even if it tries to resolve an API that belongs to kernel 32 DLL. Let's step over. Let's press a breakpoint here and here, press F9. You see that it's going to write the first API here in ESI. And also here. So let's press F9 again. You see now it has resolved an API that belongs to kernel 32, but it's going to write the real address, and again in EDX here it's going to write the real address. So let's remove the breakpoints from here and place a breakpoint here at the end of the function and press F9 to run. You see that now the pointers are not redirected anymore. These are the pointers for kernel 32. So let's go back. Place a breakpoint here, run, step over. Let's continue the execution. Let's place another breakpoint here at the end of this function. Step over again. We see we already have the breakpoint here at jump EX, so press just F9. Ctrl plus A to reanalyze. And you see now that the pointers are correctly placed in the import address table. There are no redirected pointers. So let's now try to dump and unpack the application. Let's save this as P compact. Anti-debug. And then let's fix the imports. Let's see, the first one is a close key, and the last one retrieved is this one here. So it seems everything is fine. Let's just fix the imports, add the new imports table, and let's try to run it, and we see that it runs perfectly. Let's load it again to Oli Debugger. This time we load the unpacked one with the fixed imports. and you see that everything now is fine. We start from the original entry point of the application. The pointers to the APIs are correctly placed inside the import address table. No imported directions anymore. So we managed also to unpack pcompact with some basic anti-debugging techniques, some basic debugger detection feature, and also imported direction feature, which is a more advanced protection. And we managed also to fix also that issue. So I hope that you had fun through these unpacking demonstration videos and that you really learned something from them. Unpacking is a very important skill that you should have, especially if you are planning or you are already working as a malware analyst, since many malware authors use simple packers like the ones we demonstrated during these videos to pack their malicious executables and make them more hard to detect by antivirus products. So that was it. Have fun.